Hello, this is Mrs. Sargent, and this is lesson 8.5, Solution Concentration. So the first thing that we need to talk about is what is concentration. Concentration is the amount of solute that is dissolved in a given quantity of solvent, and this can be expressed in the forms of molarity, percent by mass, and percent by volume. So these are the three types of concentration that we will discuss today. And the given quantity of solvent is important because if you have more solvent, you will be able to dissolve more solute. Just as a reminder, solute and solvent, the solute is the dissolved particles in a solution. And today what's going to be key is that this is going to be the lesser amount. And then solvent is dissolving medium in a solution. So it's going to be what dissolves the solute, and it's going to be in the greater amount. You don't have a place to write these down. Those are just in review of things that we've already talked about. And then to find the total amount of solution, you're going to take the solute plus the solvent to determine the total amount of solution. I would go ahead and write this down. Okay, so finding percent by mass, your equation is going to be the mass of the solute divided by the mass of the solution, multiply it by 100 to get a percentage. So again, the solution, this is where the solute plus solvent comes into play. Now you don't have this example in your packet, but you might want to go ahead and write down the calculations just as an example problem. So you are given 3.6 grams of sodium chloride, and it is dissolved in 100 grams of water. You want to determine the percent by mass. So first we have to determine what is our solute and what is our solvent. Well, remember we said that the solute is going to be in lesser amount. So that in this case is going to be the 3.6 grams of sodium chloride. And the solvent is going to be the 100 grams of water. It is in greater amount. So we're going to add these together to get our total amount of solution. It's going to be 103.6 grams. So now we can take our equation and start plugging things in. So percent by mass equals 3.6 grams of our solute divided by the 103.6 grams of our solution and multiply that by 100. And you should get 3.5% for your answer. Percent by volume is very similar, but this is going to occur when both the solute and the solvent are liquids. So percent by volume is the volume of the solute divided by the volume of the solution. Again, multiply it by 100 to get that percentage. So what is the percent by volume of ethanol in a solution that contains 35 milliliters of ethanol and 155 milliliters of water? So our solute is going to be the ethanol. And the 155 milliliters will be the solvent of the water. Add those together we get 190 milliliters of solution. So we're going to plug in percent by volume equals 35 milliliters of ethanol divided by 190 milliliters of solution. Multiply it by 100, and you should get 18%. The other calculation that you will see typically in chemistry is molarity. And so the equation for molarity equals the number of moles divided by the liter of solution. You will also see this equation. The capital M stands for molarity. The lowercase n is your number of moles divided by your volume, which will always be in liters for molarity. Now remember, for your volume, again, you're going to need the solute plus the solvent. Typically in molarity, the volume is going to be your total solution volume, you won't have to do any calculation for it. So here we have two different beakers. One has 10 grams of sugar and 150 milliliters of water. The other has 10 grams of salt and 150 milliliters of water. Go ahead and pause the video. I want you to write down which solution you think is more concentrated and why. Okay, go ahead and pause it. Welcome back. So you should have a reason written down for why you think the solution is more concentrated. Remember, this is just a prediction. We're going to go through the calculations to determine which one is more concentrated. So we are given a mass of both of our solutes. So the first thing that we need to do is we need to convert it to moles, because remember, our molarity equation has the number of moles, not a mass. So we're going to convert this to moles. Since we have a mass, we need to convert it to the molar mass. So just a reminder, to find molar mass, you're going to split it into each element. Look up the average atomic masses. Then multiply by the number of atoms. So we have 6 carbon, 12 hydrogen, and 6 oxygen. So our total molar mass for sugar should be 180.18 grams per mole. So since we have grams on the top, we're going to put grams on the bottom. So 180.18 grams of C6H12O6. 1 mole on the top. Grams is going to cancel. We'll be left with moles. So 10 divided by 180.18 should give us 0.0555 moles. And then in our molarity equation, molarity equals number of moles, so 0.0555 divided by the volume, but it needs to be in liters, and it's in milliliters. Well, there is 1,000 milliliters in 1 liter. So you can either divide this by 1,000 to get your liters, or you can move your decimal 3 places to the left. So our volume for both of these is going to be 0.150 liters. So we're going to plug that in here, 0.150 liters. This is my moles on top. 0.0555 divided by 0.150 should give us a molarity of 0.37 molar. C6H12O6. Now we're going to do the same thing for our sodium chloride solution. We're given a mass, so we need to convert this to a molar mass. So sodium and chlorine, we have one of each of these. Multiply them by 1, but they're still going to have the same mass. 22.99 plus 35.44 should give us a molar mass of 58.44 grams per mole. And grams on top, so we're going to put grams on the bottom. Grams of sodium chloride is going to cancel. 10 divided by 150, or 10 divided by 58.44 is going to give us 0.1711 moles. So now in our molarity equation, 0.1711 moles divided by 0.150 liters. That is going to give us a molarity of 1.14 molar sodium chloride. So our sodium chloride solution is more concentrated, since this is 1.14 molar and this is 0.37 molar. It all has to do with the molar mass, though, and determining, since we have the same amount of solute and the same amount of solution. Right, and this next problem says, what is the molarity of an aqueous solution containing 40 grams of potassium iodide and 1.50 liters of solution? I'd like you to pause the video and try this one on your own. You're going to need to convert grams to moles, but your volume is already in liters. Welcome back. So we have 40.0 grams of potassium iodide. We need to convert that to moles. So we first need to find the molar mass. The average mass of potassium is 39.10, and the average mass of iodine is 126.90. Add those together and you should get 166 grams per mole. Grams of potassium iodide is going to cancel. 40 divided by 166 is going to give you 0.241 moles of potassium iodide. So now we need to plug it into our molarity equation. 0.241 moles of potassium iodide divided by 1.50 liters. That is going to give us 0.161 molar solution of potassium iodide. Okay, so both of these examples that we've looked at, we've been calculating molarity straight from a mass to the molarity of a solution. But I want to take a look at using the molarity equation when we're trying to find something other than molarity. So in this problem, it says how many grams of copper nitrate, copper 2 nitrate, would be dissolved in 1.3 liters of solution with a 0.10 molar solution. So let's take a look and plug in what we know. So in our molarity equation, remember it's molarity equals the number of moles divided by the volume. So we have the molarity, so we're going to plug in 0.10 molar. We don't know the number of moles, so we're just going to leave that as N, but we do know the volume, and that's 1.3 liters. So if we find our number of moles, then we can find the mass of copper nitrate. So what we're going to do is we're going to do some cross multiplication. Anytime you have a whole number, you can put it over 1, and then you're just going to cross multiply. So you're going to take 0.10 times 1.3, and that should give you 0.13. And then 1 times N is going to equal N. So this is 0.13 moles is what is equal to N. So now we can take that 0.13 moles and plug that in, and then calculate the molar mass to determine the mass of copper nitrate. So copper is 63.55 average atomic mass. Nitrogen 14.01, and oxygen is 16. We only have 1 atom of copper, we have 2 atoms of nitrogen, and 6 atoms of oxygen. So 14.01 times 2 is going to give you 28.02. 16 times 6 is going to give you 96. Add these together and you should get a molar mass of 187.57 grams per mole. Cancel out the moles. 0.13 times 187.57 will give you a mass of 24.38 grams of copper nitrate. In our next example here, it says how many milliliters of water are needed to make a 2.50 molar calcium chloride solution containing 35 grams of calcium chloride. So we want to find the volume. So again, let's plug in what we know at this point. We know the molarity, which is 2.50 molar. We don't know the number of moles, and we don't know the volume. Milliliters is another unit of measurement for volume, so that's what we want to find. We want to find V. The other information that we're given is 35 grams of calcium chloride. So we can convert this grams 2 moles and plug that into our equation. So again, we're going to need to calculate the molar mass of calcium chloride. The average atomic mass of calcium is 40.08. Chlorine is 35.45. Multiply this by 2. Multiply this by 1. When you add those together, you should get a molar mass of 110.98 grams per mole. Grams of calcium chloride is going to cancel. 35 times 1 is 35 divided by 110.98, and you should get 0.3315 3154 moles of calcium chloride. So now we can plug this in to our equation. So 2.50 over 1, and then 1 times there. So we're going to take 1 times 0.3154, which is going to give us 0.3154. And then V times 2.50, so this is going to be 2.50V. Divide by 2.50 on both sides in order to get V by itself. 2.50 cancels out. V divided by 0.3154 should give us a volume of 0.126. Remember, volume is in liters at this point. So now we need to convert our liters into milliliters. And we can do this by multiplying it by 1,000 or moving our decimal 3 places to the right. So our volume is going to be 126 milliliters of water. Okay. So how to make a solution? There's 4 steps that you're going to need to make a 500 milliliter solution of a 0.1 molar sodium hydroxide. The first thing you need to know is that sodium hydroxide is a solid, and you first need to determine how much solid sodium hydroxide you're going to need. So we're going to do another calculation. We have a 0.10 molar sodium hydroxide solution, and we need 500 milliliters of it. So we're going to plug in 0.10 molar. We don't know the number of moles, but we do know there's 500 milliliters. Convert milliliters to liters, move 3 places to the left, so 0.500 liters. Cross multiply. So 0.5 times 0.1 is going to give you 0.05 equals N. 1 times N is N. So this is our number of moles. So now we can take those number of moles and convert it to a mass. So now we need to calculate the molar mass of sodium hydroxide. Sodium is 22.99. Oxygen is 16. And hydrogen is 1.01. Add those together and you should get 40.00 grams per mole. .05 times 40 is going to give you a mass of 2 grams of sodium hydroxide. So you're going to mass out 2 grams of sodium hydroxide on the electronic balance. You're going to dissolve the 2 grams of sodium hydroxide in a small amount of distilled water. Pour it into a volumetric flask. And then you're going to fill with distilled water up to this line that is 500 milliliters. And volumetric flasks are just more precise than an Erlenmeyer flask, and that's why we use it for making stock solutions like a 0.1 molar sodium hydroxide solution. Alright, you have practice problems on page 11 to take a look at, work through those. And then your book assignment is page 481, numbers 9 through 11, and page 482, numbers 14 and 15. Make sure you work through these problems. If you have any questions, feel free to stop by and ask me. Thanks for stopping by. Have a great day.